2014 Physics Senior External Exam, Paper 1, Part A, Section 1, Short Response, Question 3. A 900 kilogram car, so we have a mass of 900, travelling at 20 meters per second. We have a velocity, crashes into a barrier and comes to a complete stop in 8 by 10 to the negative 1 second, so we have a time. What is the magnitude experienced? What is the magnitude of the impulse experienced by the car? So we have a car. The car hits a barrier. So there's our barrier here. Mass is 900. So we talk about the initial momentum being the mass by the velocity. So that's our formula. We lock in the values. 900 minus 20 let's turn that on. 900 times 20 equals 18,000 kilograms meters per second. That's the initial momentum. The final momentum is 0 because it crashes into the barrier and comes to a complete stop. So initial velocity was 20, final velocity is 0. Now, our change in our momentum is our final minus our initial, so is negative 18,000 because it's a reduction in momentum. Now, we're after the magnitude of the impulse. Now, magnitude means we're not worried about increases or decreases, just the change. So, impulse is change in momentum, so it's force by change in time, mass by change in velocity. What's the magnitude of the impulse? The magnitude of the impulse is 1.8 by 10 to the 4, and it's either kilograms meters per second or newtons second. There's part A. Part B. What's the work done? Work equals change in energy. In this particular case, it's the change in the kinetic energy. So it's the final minus the initial. It has no kinetic energy at the end, and again, work is a scalar, so all we're after here is the change in the kinetic energy. A half times 900 by 20 squared. 900 divided by 2 equals 450 times 20 times 20 equals 180,000. 180,000. So therefore we look at trying to get this here. 1.8 by 10 to the 5 joule.